Hello friends, myself Aradi Mahajan presenting my one more video on function of complex variable integral calculus, Cauchy's integral formula. Let us evaluate contour integral of cos z divided by z multiplied by z square plus 8 with respect to z over closed curve C, where that C is a boundary of the square whose sides lie along the lines x is equal to plus 2, x is equal to minus 2, y is equal to plus 2 and y is equals to minus 2. And therefore, to determine the value of that contour integral, we consider that f of z as cos z. It is an analytic function, and then to determine the pole, we have to equate the terms from denominator to 0. We get z is equals to 0 as a simple pole. It is pole of order 1. Then second term, z square plus 8 is equals to 0. It implies z square is equals to minus 8. Transferring that plus 8 to right hand side, we get minus 8. Taking square root on both sides, we get z is equal to root of minus 8. 8 we can write down as 4 to the 8. Square root of 4 is 2, root 2, and root of minus 1 is I. Therefore, the values are z is equals to plus 2 root 2 I and z is equals to minus 2 root 2 I. These are two simple poles. And therefore, we have to determine whether that pole lies inside or on or outside that curve C. Here the curve C is a square. Therefore, try to draw the square in xy coordinate system. X-axis, y-axis, point z is equals to 0, means x is equal to 0, y equal to 0. Then x is equal to plus 2, a line parallel to y-axis, that is x is equals to 2. Exactly on the same distance on left hand side, we have x is equal to minus 2. Then y is equal to plus 2 and y equal to minus 2. Therefore, these are the four sides of that square. Therefore, this is that closed region. Direction is anti-clockwise. And then we check whether the points z is equals to 0. Z equals to 0 means x plus iy, that is 0 plus 0i. X is 0, y is 0. Therefore, this origin is the point z is equals to 0. And from the figure, it is very, very clear that that point lies inside that curve C. Then we determine the second. It is z is equals to 2 root 2i. As it is imaginary point, it lies on y-axis. The distance from the origin is 2 root 2, some greater than 2. Therefore, this is the point z is equals to 2 root 2 I, and z is equals to minus 2 root 2 I. This is that point z is equals to minus 2 root 2 I, and this 2 point lies outside that curve C. It means 2 point lies outside the curve C and 1 point lies inside the curve C. And therefore, by applying that Cauchy's integral formula, we try to get the value of that contour integral. Then applying Cauchy's integral formula, the value of that contour integral of cos z upon z into z square plus 8 dz, the point which lies inside that we keep in denominator, and whatever the point outside that we shift in numerator. Therefore, we have integration of cos z divided by z square plus 8 and whole divided by z, and its integration with respect to z by Cauchy's integral formula. Its value is 2 pi I multiplied by f of z. F of z here cos z divided by z square plus 8 at z is equals to a is here 0. And therefore, substituting z is equals to 0, we get the value as 2 pi I cos 0 divided by 0 plus 8, we get 8. And it is 2 by 8, we get pi I by 4, and cos 0 is 1. And therefore, the value is pi by 4 into I. as the answer or the value of that contour integral by applying Cauchy's integral formula. One more I will discuss in my next video. Therefore, if you like my videos, please share it as well as subscribe to my channel to receive the notification for my new videos. For that, you have to press the bell icon. Thank you. Thanks for watching.